The tail gunner's body hung halfway out of the shattered turret. Staff Sergeant Michael Chen pulled him back inside. The gunner wasn't breathing. Chen checked for a pulse. Nothing. He laid the body against the fuselage wall and turned back to his position. Through the destroyed tail section, he could see sky. Not through a window. Through a 9-foot hole where the vertical stabilizer used to be. The B-17F, Liberty's last, was flying at 18,000 feet over occupied France with half its tail missing. The aircraft should have been in an uncontrolled spin. Should have already crashed. But somehow, pilot Captain James Harrington was keeping it airborne. The control yoke was shaking so violently in his hands that he couldn't feel his fingers anymore. The rudder pedals were responding, but barely. Every input took 3 times the normal force. In the navigator's compartment, Lieutenant Robert Walsh was calculating their position. They were 287 miles from RAF Bassingbourn. They had 340 gallons of fuel remaining in the Tokyo tanks. At their current speed of 142 miles per hour, accounting for headwinds, they had maybe 2 hours and 20 minutes of flight time. The math worked. They could make it back to England, if the aircraft stayed together, if the controls kept responding, if nothing else failed. At 5:30 hours, the briefing officer pulled back the curtain on the mission map. Red yarn stretched from Bassingbourn to Stuttgart, 512 miles each way. The target was the Bosch Magneto factory. Bomber Command wanted it destroyed. German aircraft engines depended on Bosch Magnetos. No Magnetos, no engines. No engines, no fighters. The logic was simple. 24 B-17s from the 381st Bomb Group would hit the factory. They would fly in 4 box formations of 6 aircraft each. Liberty's last would fly position 5 in the lead box, right wing slot. Standard formation spacing, 150 feet between aircraft, 300 feet between elements. The intelligence officer showed reconnaissance photos of the factory. 3 main production buildings, each 400 feet long, 200 feet wide, estimated 2,000 workers per shift. The aiming point was the center building's northwest corner. A perfect hit there would collapse all 3 structures. Expected fighter opposition, 40 to 60 Bf-109s and Fw-190s. Expected flak, heavy and accurate between Stuttgart and the target. Altitude for bomb run, 24,000 feet. The bombers would assemble over Orfordness, cross the channel at 8,000 feet, climb to bombing altitude over France. At 06:15, the crews walked to their aircraft. Chen carried his toolkit and a thermos of coffee. He was the flight engineer, responsible for monitoring every system on the aircraft. Engines, fuel, hydraulics, electrical, oxygen. If something broke in flight, Chen would have to fix it. If it couldn't be fixed, he would have to tell the pilot what they could still do and what they couldn't. Liberty's last had flown 31 missions. The aircraft had taken flak damage on 19 of those missions. It had returned on 2 engines twice. It had landed with 1 main landing gear collapsed once. The ground crew chief told Chen the aircraft was tired. The airframe was accumulating stress cracks. The number 3 engine was burning oil. The turbochargers were losing efficiency, but it was still mission capable, so it would fly. The 4 Wright R-1820 Cyclone engines started it at 6:45. Each engine produced 1,200 horsepower at 2,500 RPM. Chen monitored the gauges as Harrington ran through the checklist. Oil pressure, 75 psi on all 4 engines. Oil temperature, 60 degrees Celsius, rising. Cylinder head temperature, normal. Fuel pressure, 14 psi, all systems nominal. At 07:02, Harrington released the brakes and Liberty's last began rolling. The bomber weighed 54,000 pounds fully loaded, 2,500 pounds of bombs in the bay, 2,780 gallons of fuel, 10 crew members, 13 .50 caliber machine guns, 4,750 rounds of ammunition. The aircraft needed 3,600 feet of runway to reach takeoff speed. At 95 miles per hour, Harrington pulled back on the yoke. The B-17 lifted off the runway at 07:06. The gear came up, the flaps retracted. The aircraft climbed at 700 feet per minute, heading east toward the assembly point. 20 minutes later, all 24 bombers were in formation. The lead box took point. Liberty's last settled into position 5, 150 feet off the lead box leader's right wing. The formation turned southeast and began climbing to 8,000 feet for the channel crossing. The German fighters hit them 40 miles inside France. 12 Bf-109Gs came in from the front, head-on passes at a closing speed of 550 miles per hour. The combined velocity left each fighter pilot approximately 2.1 seconds to aim and fire before breaking off to avoid collision. The first 109 opened fire at 800 yards. 20mm cannon shells and 7.92mm machine gun rounds tore through the formation. A B-17 in the low box took hits in the number 1 engine. The engine caught fire. The pilot feathered the propeller and triggered the fire extinguisher. The fire went out, but the bomber had lost 25% of its power. 2 more 109s focused on Liberty's last. Shells punched through the nose section. The bombardier, Lieutenant David Morrison, felt something hit his left leg. He looked down. A shell fragment had torn through his flight suit and embedded in his shin bone. Blood was pooling in his boot. He grabbed a first aid kit, sprinkled sulfur powder on the wound and wrapped it with gauze. Then he went back to his position. The bomb run was still 90 minutes away. He would deal with the injury later. The fighters made 4 passes, then broke off. The formation had lost 2 aircraft. 1 B-17 was trailing smoke from 2 engines but staying with the group. Another had fallen back 2 miles with 1 engine out. The remaining 21 bombers pressed on towards Stuttgart. At 10:15, the flak began. The German 88mm guns had a maximum effective ceiling of 26,000 feet. The B-17s were at 24,000 feet, well within range. The first shells burst 200 feet below the formation. Black smoke puffs appeared in clusters of 4. The Germans were firing battery salvos, 4 guns at once, trying to bracket the formation's altitude. Chen watched through the waist gun window as the flak tracked closer. The shells were bursting at the right altitude now, but still 100 yards behind. The German gunners were calculating lead based on the formation's speed and direction. Each correction brought the bursts closer. At 10:23, the flak found them. A shell exploded 50 feet off Liberty's last's right wing. Shrapnel ripped through the fuselage. The number 4 engine took hits. The oil pressure gauge dropped from 75 psi to 40 psi in 6 seconds. Chen called it out on the intercom. Harrington watched the gauge. If the pressure dropped below 30 psi, he would have to shut down the engine. An engine running with no oil pressure would seize within minutes. The pressure stabilized at 38 psi. Damaged, but still functioning. Harrington left it running. They would need all 4 engines for the bomb run. The formation was 12 miles from the target when the FW-190s attacked. 8 aircraft, coming in from the high 6 o'clock position. The angle gave them a clear shot at the bombers' tail sections and minimized their exposure to defensive fire. The tail gunner on Liberty's last, Staff Sergeant Thomas Reed, tracked the lead 190 in his sight. The Fokke Wolf was diving at 400 miles per hour, closing fast. Reed opened fire at 600 yards. His twin 50 caliber guns fired 1,600 rounds per minute combined. The tracers arced toward the 190. No hits. The German fighter was jinking, making small, unpredictable movements that threw off Reed's aim. At 300 yards, the 190 opened fire. 4 20mm MG-151 cannons, firing at 740 rounds per minute per gun. The shells converged on Liberty's last tail section. The first rounds hit the horizontal stabilizer, tearing through the aluminum skin and severing control cables. More shells hit the vertical stabilizer, the large fin that kept the aircraft flying straight. The fin's internal structure, a series of aluminum ribs and stringers, disintegrated under the impact. Then a shell hit the tail gunner's position. The explosion killed Reed instantly and blew out the back of the turret. The vertical stabilizer, already severe damaged, tore away from the fuselage. The entire 15-foot-tall fin separated from the aircraft and tumbled away, falling 24,000 feet to the ground below. The B-17 yawed hard to the right. Without the vertical stabilizer, the aircraft had no directional stability. The nose wanted to weather vane into the relative wind. Harrington pushed the left rudder pedal to the floor. The rudder was still attached, but with the vertical fin gone, the rudder had lost most of its effectiveness. The aircraft's yaw slowed but didn't stop. Chen unbuckled and moved aft to assess the damage. He pushed past the radio operator, past the ball turret, into the waist gun compartment. The two waist gunners, Sergeants Frank Miller and Joseph Torres, were pressed against the fuselage wall, staring at the gaping hole where the tail section used to be. Wind was screaming through the opening at 140 miles per hour. The temperature was minus 32 degrees Fahrenheit. The noise made communication impossible. Chen clipped his oxygen hose to the walk-around bottle and moved to the hole. He grabbed a structural member and leaned out, looking at the damage. The vertical stabilizer was completely gone. The horizontal stabilizers, the smaller fins that controlled pitch, were still attached but heavily damaged. Half the elevator control surface on the right side was missing. The rudder was intact but was flexing in the airstream, attached by only 2 of its 4 hinge points. He pulled back inside and made his way forward to the flight deck. He tapped Harrington's shoulder and shouted over the engine noise. Vertical stab is gone. Horizontal stabs are damaged. Rudder is barely attached. We're missing the tail gunner. Harrington nodded. He was fighting the controls constantly, making small corrections to keep the aircraft from entering a spiral. Can we make it back to England? Chen did the calculation in his head. The aircraft was controllable, barely. The engines were running. They had fuel. The biggest problem was the bomb load. They were still carrying 2,500 pounds of bombs. The extra weight was making the aircraft tail heavy, which was amplifying the control problems. We need to drop the bombs. We're 9 miles from target. If we keep the bombs, we're not making it back. Harrington looked at the instruments. The aircraft was burning fuel faster than normal because he was constantly applying power corrections to maintain stability. The number 4 engine's oil pressure was down to 35 psi. If that engine failed, they would lose so much power that the control problems would become insurmountable. Morrison, are you on target? In the nose, Morrison was hunched over the Norden bomb site. His leg was throbbing, but he had the aiming point in his crosshairs. I have the target. Recommend we complete the run. Harrington made the decision. We're going in. The formation began the bomb run at 10:44. The aircraft straightened out on the heading to the target. For the next 3 minutes, the pilots would fly straight and level, making no evasive maneuvers. The bombardiers controlled the aircraft through their bomb sights, making minor adjustments to stay on the aiming point. This was when the bombers were most vulnerable. The flak intensified. The German gunners knew the Americans were committed to the straight run. Shells burst continuously around the formation. Liberty's last took multiple hits. Shrapnel punched through the wings, the fuselage, the engine nacelles. The number 2 engine's coolant temperature spiked. Chen watched the gauge climb past the red line. He told Harrington, "How long can it run hot? 5 minutes, maybe 6. Give me 6. Morrison made the final adjustments to the bomb site. The crosshairs settled on the northwest corner of the center building. At 10:46 per 37, the bomb release circuits activated. The bomb bay doors opened. 2 seconds later, the bombs dropped free. 2,500 pounds of high explosive fell toward the factory below. Morrison watched through the sight as the bombs hit. The explosions walked across the target buildings. Multiple direct hits on the center structure. Secondary explosions followed as stored materials ignited. Mission accomplished. Harrington felt the aircraft lighten as the bombs released. The tail-heavy condition decreased immediately. The controls became marginally more responsive. We're heading home. The formation turned northwest, back toward England. Liberty's last fell back from its position. The damaged aircraft couldn't maintain formation speed. Harrington throttled back the engines to conserve fuel and reduce stress on the damaged tail structure. The bomber dropped to 200 yards behind the formation, then 400 yards, then half a mile. The other B-17s pressed on. Standard procedure. Damaged aircraft were on their own. The formation couldn't slow down for stragglers. Slower meant more time in the target area, more exposure to fighters and flak. Liberty's last would have to make it back alone. At 11:03, the number 2 engine failed. The coolant system had lost too much fluid from the flak damage. The cylinder head temperature exceeded 290 degrees Celsius. The engine seized. Harrington feathered the propeller and shut down the fuel flow. 3 engines remaining. Chen recalculated their fuel consumption. With 3 engines at current power settings, they would burn 280 gallons per hour. They had 280 gallons remaining, exactly 1 hour of fuel. They were 198 miles from the English coast. At their current speed of 127 miles per hour, the flight would take 93 minutes. They were 33 minutes short of fuel. "We need to increase speed," Chen said. "If I increase speed, the tail structure might fail. If we don't increase speed, we run out of fuel over the channel." Harrington pushed the throttles forward. The 3 remaining engines increased to 2,350 RPM. The airspeed climbed to 151 miles per hour. The aircraft's tail section began vibrating. The damaged horizontal stabilizers were creating turbulent airflow. The vibration frequency matched the natural resonance of the tail boom structure. The entire aft section of the fuselage was oscillating. Chen felt the vibration through the deck plates. This was dangerous. Resonant vibration could cause structural failure. But they had no choice. They had to maintain speed, or they would ditch in the channel. At 11:47, they crossed into Belgium. Still 140 miles from England. Still 54 minutes of flight time. The fuel gauges showed 210 gallons remaining. The math was getting tighter. The number 4 engine's oil pressure was down to 28 psi. Chen was watching it constantly. At 25 psi, they would have to shut it down. If they lost another engine, they wouldn't make it. At 12:18, they reached the Channel coast. The white cliffs of Dover were visible ahead. 52 miles to Bassingbourn. 21 minutes of flight time. The fuel gauges showed 95 gallons. They might make it. Might. Walsh came forward from the navigator's station. He'd been doing calculations. "We have a problem." Harrington didn't take his eyes off the instruments. "What kind of problem?" "Landing problem. The horizontal stabilizers are damaged. We don't know how much elevator authority we have left. If we can't control pitch during landing, we'll either stall and drop in, or we'll come in too fast and overrun the runway." Chen had been thinking about the same issue. "We need to test the elevator response before we try to land." "Test how?" "Slow flight. Reduce power. See how the aircraft behaves at landing speed. If the controls don't respond properly, we'll know before we're committed to the landing." Harrington brought the power back. The airspeed decreased to 115 miles per hour, then 105 miles per hour, approaching stall speed. He pulled back on the yoke, trying to raise the nose. The yoke moved backward, but the nose barely responded. The elevator cables were damaged. The controlled surface movement was maybe 40% of normal. "I don't have enough elevator authority to flare for landing," Harrington said. "If I try to land this aircraft normally, the nose gear will hit first. The gear will collapse. We'll cartwheel." Walsh nodded. "We could bail out." 9 men, over civilian territory, parachutes deployed at low altitude. What are the survival odds? Better than landing this aircraft. Chen was staring at the damaged tail section, thinking, there had to be a solution. Some way to control pitch without the elevators. Some way to modify the aircraft's behavior so that a safe landing was possible. And then he saw it. The answer was so simple he almost laughed. "The waist guns," Chen said. Harrington looked at him. "What about them?" "We use them as ballast. We move weight forward and aft to control the aircraft's pitch attitude. If we shift weight toward the tail, the nose comes up. Shift weight forward, the nose goes down. We can control our descent rate without the elevators. We don't have enough movable weight. We have ammunition, 3,000 rounds in the waist gun positions. Each 50 caliber round weighs 4 ounces. That's 750 pounds of ammunition. We also have the crew. Miller and Torres are in the waist. Each man weighs about 180 pounds with gear. That's 1,110 pounds of movable weight total." Walsh started calculating. The moment arm from the waist position to the centre of gravity is approximately 8 feet. 1,100 pounds at 8 feet gives us 8,800 foot-pounds of pitching moment. The tail's moment arm is 22 feet. To generate the same pitching moment at the tail, we'd need 400 pounds. We have more than enough weight. Harrington was sceptical. "You want to control this aircraft's landing attitude by having 2 men run back and forth carrying ammunition cans?" "Yes, that's insane. Do you have a better idea?" Harrington looked at the fuel gauges. 67 gallons remaining, 14 minutes of flight time. Bassingbourn was 9 minutes away. They were committed. "Set it up," Chen moved aft to the waist gun compartment. He explained the plan to Miller and Torres. They would need to move ammunition from the front of the waist compartment to the rear, or from the rear to the front, based on commands from Harrington. The commands would be simple. Weight aft meant move ammunition toward the tail. Weight forward meant move it toward the nose. Speed was critical. They would have maybe 5 seconds to shift the weight, or the aircraft would enter the wrong pitch attitude for landing. Miller looked at the ammunition cans. Each can held 400 rounds and weighed 100 pounds. How much do we move for each command? 2 cans minimum, 4 cans if he calls for maximum input. You realize we're going to be doing this while the aircraft is landing, while it's descending at 600 feet per minute, in an aircraft that's missing half its tail and is shaking itself apart. Yes. Torres shook his head. This is the dumbest thing I've ever heard. Let's do it. Bassingbourn Tower cleared Liberty's last for straight-in approach to runway 24. Harrington set up for a long, shallow descent. 8 miles out, altitude 2,000 feet, airspeed 120 miles per hour. He lowered the landing gear. The gear extended normally. One less problem. At 6 miles, altitude 1,500 feet, he reduced power. The aircraft began descending at 400 feet per minute. Too fast. The nose was dropping too quickly. Weight aft! In the waist, Miller and Torres grabbed 2 ammunition cans and dragged them toward the tail. 200 pounds shifted aft. The nose came up slightly. The descent rate decreased to 350 feet per minute. Better, but still too fast. More weight aft. They moved 2 more cans. The nose came up further. Descent rate 280 feet per minute. Still too fast, but manageable. At 4 miles, altitude 900 feet, the aircraft was stable. Harrington maintained power settings. The nose attitude was slightly high, which was giving them extra drag and slowing their descent. As long as the weight stayed in the tail, they would be okay. At 2 miles, altitude 450 feet, the number 4 engine quit. The oil pressure had finally dropped below critical. The engine seized and stopped. Harrington feathered the propeller. 2 engines remaining. The asymmetric thrust pushed the nose left. Harrington compensated with right rudder, but the rudder was barely functional. The aircraft drifted left of centerline. He added power on the right engine, reduced power on the left. The asymmetry increased, but the aircraft straightened out. At 1 mile, altitude 200 feet, they were lined up with the runway. Descent rate 300 feet per minute. Airspeed 105 miles per hour, just above stall. The aircraft was shaking violently. The tail structure was oscillating at 4 cycles per second. Harrington could see rivets popping out of the fuselage skin. "Stand by for weight shift on my mark," he called to the waist crew. 50 feet. The runway was rushing up. Too fast. "Weight aft! Maximum!" Miller and Torres threw 4 ammunition cans toward the tail. 400 pounds shifted in 3 seconds. The nose pitched up. The descent rate decreased to 150 feet per minute. Perfect. 20 feet. 10 feet. The main gear touched down. Harrington cut power on both engines. "Weight forward. Maximum." The crew threw the ammunition cans forward. The nose gear came down gently, making contact with the runway without slamming. Harrington applied brakes. The aircraft rolled 2,400 feet and stopped. They had landed with 23 gallons of fuel remaining. 4 minutes of flight time in the tanks. The number 4 engine was completely seized. The number 2 engine's cylinder head was cracked. The tail structure had stress fractures in 14 major frame members. The vertical stabilizer was gone. Half the rudder was missing. And all 10 crew members were alive. The intelligence officers interviewed Chen about the weight-shifting technique within 2 hours of landing. They wanted details. Exactly how much weight? Shifted how far? What were the pitch response times? How did the crew coordinate? Could the technique be formalized into a procedure? Chen explained the physics. The B-17's center of gravity was located at approximately 40% of the mean aerodynamic chord. Moving weight aft shifted the CG toward the tail, increasing the natural pitch-up tendency. Moving weight forward shifted the CG toward the nose, increasing the pitch-down tendency. By carefully controlling where weight was positioned during approach, they could compensate for lost elevator authority. Within a week, the technique appeared in a classified memo from 8th Air Force headquarters to all B-17 groups. The memo described weight shifting as an emergency procedure for aircraft with elevator damage. Crews were instructed to identify movable weight sources before missions: ammunition, equipment, even crew members. If elevator control was lost, these weights could be repositioned to maintain pitch control during landing. The procedure was used 17 times in the next 8 months. 14 of those attempts resulted in successful landings. The 3 failures were all aircraft with damage too severe for weight shifting to overcome, but even in those cases, the crews maintained partial control longer than they would have otherwise. By January 1944, weight shifting was part of standard B-17 emergency procedures training. New pilots practiced the technique during flight school. Flight engineers were trained to calculate required weight movements based on damage assessment. The procedure that had been improvised in desperation became Doctrine. Liberty's Last never flew again. The damage was too extensive. The aircraft was stripped for parts and the airframe was scrapped. But the technique that Chen, Harrington, and the crew developed during those final 9 minutes of flight saved lives for the rest of the war. There's a photograph in the National Archives, file number 342 FH3A25782-87234. It shows Liberty's Last on the hardstand at Bassingbourn the day after the mission. The tail section is clearly visible in the photograph, or rather, the absence of the tail section. The photo was taken from behind the aircraft. You can see straight through the fuselage, through the hole where the vertical stabilizer should be, all the way to the nose section. Written on the back of the photograph in faded pencil, "Emergency landing, November 1943. Weight shift technique. 10 men lived." That's how innovation actually happens in war. Not through official channels or engineering committees. Through flight engineers and pilots who see problems, find solutions, and don't wait for permission to save lives. If you found this story as compelling as we did, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters. Each one deserves to be remembered. And we'd love to hear from you. Leave a comment below telling us where you're watching from. Our community spans from Texas to Tasmania. From veterans to history enthusiasts, you're part of something special here. Thank you for watching, and thank you for keeping these stories alive.